Hello everyone. In this video, we are going to look how we can use Jamovi to help us create contingency tables to help us answer some basic probability questions. Okay, let's look at this following scenario. So a survey was recently given to 5 major tech companies to determine employee satisfaction. Answer the following questions. All right, so let's go ahead and open up the data. And we see that we have two columns. One column is given us to be the tech company, and the other one is given the specific employee satisfaction who worked at the company. Let's go ahead and highlight the data, let's copy it, and let's bring it over to Jamovi, and we'll paste it in. Let's go ahead and alter some of our variable information. Let's start off with the name. Let's do tech company. And no spaces, so that's why I used an underscore, or if you want to just make it one word, that's fine too. It is in fact nominal in text, but one thing that I am going to do is I'm going to reorder the levels, not because that this is actually ordinal data, it is in fact nominal, but they were given numbers in front, and so we might as well put it in order. So I'm going to take 5, move it all the way down, 4, move it down, now I've got 1, 2, 3, 4, 5. Okay, so the next one that we're going to do is we're going to do satisfaction. And this one is in fact ordinal data. It's still just text, but we have a simple little Likert scale. So we're going to move poor to the bottom, good to the top, and now we have a 1, 2, 3, good, neutral, poor Likert scale. Okay, so that's all that we need to do with organizing and kind of modifying our data. And now what we are going to do is we're going to create a contingency table. So it's a way that we can organize this data to kind of see the frequencies of these two things interacting at the same time. So let's go ahead and go to analysis, and we can go to frequencies, and we can go down to this section contingency tables and click on one that's called independent samples. Before we move anything in, we're going to go down to our statistics, and we're going to go ahead and remove, this is our chi-squared statistic, we don't need it, and the confidence intervals. These are for more complicated analyses that we will do at a later time. Now, I'm going to move the tech company over to the rows and the satisfaction over to the columns. And I'm given a basic contingency table that gives me the counts of these specific events for each specific person. So let's look at a person. There were 17 people who worked for Google and said that they had a satisfaction level of good. There were 36 people who worked at Facebook who had a satisfaction level of good, etc., etc. So we're going to go ahead and copy this, and we are going to move it over to an Excel workbook to help us out to facilitate doing the calculations. So I'm going to take these totals and highlight them as yellow. These are what are known as our marginals. Remember, they are the totals of their respective rows or columns, and then here, let's highlight this one orange, is our grand total, which is the total calculation of how many people responded to our survey. Okay, very well. So our first question that we have is this Google Union Facebook. And I'm just going to grab it and paste it right here. Google Union Facebook. Now, generically, we have probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersect B. So that's just how we do it generically. So Google could kind of be like our A event. Facebook can be our B event. So let's highlight Google. Let's make it green or something. Let's take Facebook, and we will highlight it as blue. So the first thing that we're going to want is the probability of Facebook and the probability of Google and the probability of their intersection. We'll do Google intersect Facebook. Okay, that'll work for us. So let's start off with the probability of Facebook. This one's pretty easy. We could add up all of these values that are in Facebook. These are all the people who said that they work for Facebook. We could do 36 plus 39 plus 48 divided by our total, and that would give us the probability that a randomly selected person from this sample or from the survey in fact responded that they work for Facebook. Alternatively, that calculation has already been done for us. That's 123 right here. So we can just click on 123 and divide by 500, and we have the probability of Facebook. Well, let's do the same thing with Google now. So we can do Google is 63 people from this survey responded they worked for Google, and divided by 500. I've got those. Now we're looking for the intersection. Now, intersections in contingency tables are where the two events cross, or where they overlap, where two events can be true at the same time. Now, if we look at Google and we look at Facebook, these two are actually parallel lines, and they don't cross at all. It's what's known as mutually exclusive events. And the probability that they intersect is 0. So now when we look at this calculation, we can actually get our probability of Google union Facebook. And we just can say equals Google plus Facebook minus their intersection. And what are we left with? We're left with 0.372. And if we click here, we get 0.372. Fantastic. So that's how we can do a simple union. Okay, additionally, what we can do is we can actually use some more of Jamovi to help us out with this very same calculation. What we can do is if we go to the cells and we say we want to have some percentages calculated for us, let's just get the total percentages calculated for us. Notice how it includes now an additional row in order to give us the percentage of the total of every single spot on this contingency table. Let's go ahead and copy it and bring it over to Excel. And let's paste it in. Okay, now that we have these, we can actually gather this information, this very same information that we just calculated on our own. So if we were looking at the probability of Google, we can go over to Google, go to the total, and see that it's 12.6, which is what we got over here in decimal form. 0.126 in percentage form is 12.6. Great, so we could just pull this 12.6 directly from our contingency table. Then we look at Facebook, 24.6%, and there it is right there. And the intersection is still 0. We can sum them up, and voila, we have, once again, our union using another tool from Jamovi, using this percentage of total. Okay, let's look at another one real quick. I'm going to go ahead and clear out the highlighting that we have done so far. And now let's look at Uber intersect Amazon. Great, so let's highlight Uber, and we'll make it something like orange. And let's highlight Amazon. We'll make it green. And there we go. Now we're asking for Uber intersect Amazon, or Uber and Amazon. Well, if we look at these, once again, these values are in fact mutually exclusive. They don't cross at all. So the probability that they have an intersection, or that the probability that someone, a randomly selected person from the survey, responded that they both work for Uber and Amazon, is in fact 0. So that one's easy. Let's go ahead and highlight these again and remove the highlighting. Now remember, there's nothing special about this highlighting. I'm just doing it for kind of presentation purposes. So now let's look at another intersection that we can calculate. Lift intersect pour. So let's go ahead and highlight lift. We'll make it blue. And then we'll highlight this guy, and we will make it green. Well, let's make it red. And then that way we can do the intersection as purple. And we can now just easily look at this. Okay, so where do lift and pour, oops, not neutral. We need to move those. Let's make that highlighting. Let's undo those two highlights. We'll make this one red. We'll make this one purple. And I still got it wrong. Lift, intersect, pour. Let's try it one more time. Okay. Highlight it so that it's red, and that the intersection is purple. So one of the nice things about what I just did is I was able to quickly see that I had the wrong intersection, and the color coding kind of helps me quickly look and see what I'm actually dealing with. Okay, so lift, intersect, pour is simply going to be where pour and lift intersect, and it's at this 35 value. So if I want to do the probability of lift intersect pour, that's just going to be equal to this 35 divided by 500. But remember, we can also see this intersection down here in this contingency table where we have the individual probabilities of these percentages of the total, where we could look at lift and pour, and we are given, right here, 7%, just like we found. Okay, let's go ahead and do one that's a little bit more complicated. Let's do a conditional probability. So let's talk a little bit about conceptually what does this mean. So this probability reads, what is the probability that a randomly selected person responded that they had a good satisfaction level given that they work for Amazon? So essentially what that given statement, what this second half of the statement means, it's like, only look at Amazon. We're only caring about Amazon. We don't care about any other tech company. Just looking at Amazon, what's the probability that somebody responded that they had a good satisfaction level? Okay, so here's what we can do. We can go ahead and write out this probability statement. So our probability statement is good given Amazon. And if we type it out again in generic terms, it's the probability of A given B equals the probability of A intersect B divided by the probability of B. That's it generically. So if that's the case, let's go ahead and get the probability of good intersect Amazon and the probability of Amazon. Once we have those two component parts, we can divide them by each other and get what we're looking for. So good intersect Amazon. Let's look at good and let's intersect it with Amazon. So we've got 53 divided by 500. Let's just type that out. 53 divided by 500 for good intersect Amazon. Oops. The probability of Amazon is equal to marginal total, 184 total who responded as Amazon, divided by our grand total. And now we can do the intersection divided by this probability of Amazon. And so we can just say equals this 0.106 divided by 0.386. And we can hit enter and we have this 0.28804. Okay, great. For this good given Amazon. So moving our way down, we could also grab, remember, these probabilities from good intersect Amazon. If we looked at the Amazon, we have the percentages of 10.6 or 0.106, and this total of probability of Amazon of the total is this 0.368 or 36.8%, and we divide them together, and we get this 0.28804, and we get 0.28804 for our answer. Okay, there's actually an easier way even with another additional Jamovi tool. So let's go over here and let's actually look at row percentages. So we're going to click on row, let's copy this, let's head back to Excel. Coming on down, let's go ahead and paste this in. And if you notice, we have an additional row. So we have percent within row. Very handy. So let's go ahead and highlight Amazon. And if we notice, we get Amazon, and we want to know what's the percent. So we're just looking at Amazon. And the percent within row, this is saying, just looking at Amazon, what percentage responded as good? And here it is, 0.28804. So that's quickly how we can get this conditional probability. Okay, moving right along, we're now left with a little bit more complicated. So this one is what's the probability of Google union neutral or Google or neutral complement or of not being Google union neutral. Okay, so what we're going to do is let's come back up here and look at this contingency table. And I'm just going to highlight Google, bring that across, and I'm going to highlight it as green. And then I'm going to highlight neutral and highlight it as green as well. Now, what I'm going to do is basically I want everything that's not Google or neutral. That's what that complement means, everything that's not Google or neutral. So I've got a couple ways that I could go about actually calculating this. One, I could use the complement probability, right? So the probability of A, let's do complement, is equal to 1 minus the probability of A. So let's do that one first. We can find the probability of this union and do 1 minus it. So let's go ahead and do that. 1 minus, and then this probability of this OR statement. Now I could go and do it the original way, right? Over here I could find the probability of Google plus the probability of neutral minus the intersection and then do 1 minus that. I could do that. That would work. But let's try another method as well. What I can do is I can do 1 minus the sum of all the green area. It's the exact same thing. So let's sum it up real quick. 17 plus 24 plus 22 plus 39 plus 60 plus 14 plus 19 divided by 500. That's one way to get it, this 0.061. Or if conceptually we understand that it's everything that's not the green, why don't I just highlight everything that or sum up everything that we didn't highlight in green? So what I can do is then do 36 plus 53 plus 16 plus 27 plus 48 plus 71 plus 15 plus 19 and divide it by 500. And I'm still left with 0.61, which is our answer. So fantastic. A couple different ways how you can get this a little bit more complicated and involved complement. Complements are very useful later on. So kind of remember this concept that all the complement is just everything not what you're looking at. Okay, so next, are the good and neutral responses mutually exclusive? Let's go ahead and do a little bit of highlighting again. So let's look at good. We'll make them, well, let's do blue. We'll make neutral. Yeah. Or tan, whatever. So are they mutually exclusive? So remember, mutually exclusive just means, do they have an intersection? If the intersection is 0, it means that they are mutually exclusive. If it's not 0, then they are not mutually exclusive. So if we look at this, are these mutually exclusive? They are, in fact, mutually exclusive because they do not cross. It's not possible to have somebody both respond that they have a satisfaction level of good and a satisfaction level of neutral. Okay, the next one that we have are good and neutral responses independent. Okay, so this one is a little bit tricky. So are good and neutral responses independent? If we're looking at this one, what does independence actually mean? So sometimes people think that mutually exclusive means that they are independent. That's not what it means. Let's type this out real quick. So mutually exclusive. And that basically just means that intersection is, or we'll say the probability, we'll write it out right. Probability of A intersect B is equal to 0. That's mutually exclusive in a nutshell. Independence is this guy. Probability of A given B is equal to the probability of A. So in other words, it means like the probability of event A has no impact by what probability of B is. I could know what B is, or I could not know what B is, and my probability of A does not change. So let's see if this holds up. So we've got our good and neutral responses independent. So let's look at the probability of we'll do good given neutral. And we need the probability of good. Okay, so in doing these guys, let's look at this. First of all, let's do the easy one. What's the probability of good? So we can go down and look at 149 divided by 500. All of the goods divided by the total. So 149 divided by 500. And we get, 0.298%. So if good given neutral is in fact the same as the probability of good, then we know that we have independent events. Let's check this though. Probability of good. Let's actually write this out again. Remember that this probability is going to be equal to the probability of good intersect neutral divided by the probability of neutral. Okay, so we need the probability of good intersect neutral, and we need the probability of neutral. Okay, So we can actually answer this really quickly because we know that the probability of neutral we could do, it's 156 divided by 500. What the heck, let's just do it. Equals 156 divided by 500. And good intersect neutral. Wait a second. Good intersect neutral has no intersection, so the probability is 0. So then if we go back up to this probability, it's just going to be equal to 0 divided by 0.312. And we get a probability of 0. And the probability of good was equal to 0.298. So since the probability of good and the probability of good given neutral are not the same, then good and neutral are in fact not independent. They are not independent events. They are dependent events. And in fact, most mutually exclusive events, in fact, are not independent. They are usually dependent events. We can have some contrived ways where they are, in fact, independent, but for the vast majority of the time, mutually exclusive events are, in fact, dependent. Okay, so using that same process, we could go through and do these calculations and see if Google and good are independent events, or we can kind of use some shortcuts again. So I think what I'm going to do is I'm going to use one more trick up Jamovi's sleeve to answer this last question. So let's go back to Jamovi and let's click on this final one. We'll do the column percentages as well. And let's go ahead and copy these over and bring them over to Excel. And let's go ahead and paste it in. Let's be really clear about what we need. Okay, let's lift this up. Okay, so the probability statement that we are really wanting to know is, are good and Google independent events? So if they are independent, that would be good given, or we'll do Google given good is equal to probability of Google. So we need then two statements there and just compare them to one another. Probability of Google given good, and we need to know the probability of Google. We can grab these really quickly. So first of all, Google given good. So what we would look at is just the good column. So this is a conditional statement. We could go through and do kind of the hard way, but let's save us quite a bit of work, and let's just highlight this real quick. So if we just look at good, what is the probability that, looks like I have it. Yeah. So given good, what's the probability that the respondent was from Google? So that is a column. We're just interested in this column of good. Given good, what's the probability of Google? And it's this 11%. So we could just type 0.11409. And then we need to know the probability of Google. And the probability of Google total over here is percent of total is 12.6. So we can do 0.126. Now we just compare these two. Are the two the same? And they, in fact, are not. Oh, sorry. Yes, that is correct. And so if we look at these, we can say that, okay, how do I know from these statements which is the correct one? So let's go ahead and look. We're looking at good, Google given good, so we know it's not this union one, so we're looking at these ones, and that it's equal to Google. Okay, so we've got these three. We got those three that look correct. And then we come over here and we say Google intersect good was this 114.114. Then we come over here and we know that Google is 0.126, so these are good. And they do not equal one another, so therefore they are dependent events. So that's how you go through and use our contingency table. So these are kind of all the tricks that Jamovi has in order to help us out with our contingency tables and to help us facilitate answering these questions inside of MyOpenMath, and how we can use our contingency tables to answer basic probability questions. Good luck on your application of these principles.